Welcome to lesson 21 of GMAT Math Basics. Let's talk about the basics of inequalities. Now that you understand equations, we can discuss a concept we use to represent values that are not equal or not always equal. We call these expressions inequalities. Examples of inequalities include expressions like x is greater than 3 or y is less than or equal to 100. Inequalities represent ranges of values that are not necessarily fixed. Hence, they can help us model many real world situations where quantities vary beyond what an equation could represent. So they're very, very useful. They are also frequently tested on the GMAT. So let's make sure you are set up well with the basics. Before we dive in, as always, here's a quick quiz covering what we'll discuss today. Feel free to revisit this information over time if you find it helpful. Question number 1. What is an inequality? Question 2. How do you depict inequalities visually? How do you draw them? Question 3. How do we operate on inequalities? How do we simplify them? Question 4. What are compound inequalities? Question 5. How do you visualize inequalities on a number line? Let's go. Number 1, what is an inequality? As I said earlier, inequalities represent relationships between quantities that are not equal or not always equal. The way we represent these relationships is by using a few distinct symbols. Let's start with the first one, which is usually called a greater than symbol. If you want to show that a quantity x is larger than a quantity y, you'll use this greater than symbol. If you hit the shift key on your keyboard and then type the period key, you'll see what I'm talking about. It's kind of like a triangle with no base that's been rotated 90 degrees to the right, or 90 degrees clockwise, if that makes more sense to you. The bottom of the original triangle that's open is now open to the left, and the two sides narrow down until they touch each other to the right of the shape, at the very right of the shape. So it's kind of like a triangle that had no bottom, and then it was rotated 90 degrees to the right so that the kind of pointy part of the triangle is facing the right. And what that represents is that the quantity to the left is the larger quantity, and the quantity to the right is the smaller quantity. The two sides taper down and narrow until they point to the smaller value. That's called the greater than symbol. An example would be 10 is greater than 5. So if we have 10 and then we have this greater than symbol, then the bottom of the triangle that's was previously missing is going to be facing the 10. That's the larger side. And then the two sides of the triangle are going to narrow down to what used to be the top of it, and that's going to face the right and point toward 5. Hopefully that helps you understand the way that we draw and use that symbol. If we want to show that a quantity is less than another quantity, then we use the less than symbol, which is kind of just like the greater than symbol, but flipped or inverted. If you hit the shift key on your keyboard and then type the comma key, you'll see what I'm talking about. This is exactly the same shape as the greater than symbol, meaning it is a triangle with no base or no bottom, but instead of rotating the triangle to the right, we rotate it 90 degrees to the left or counterclockwise. So the part with no base actually opens to the right now, and the two sides taper down until they touch at the left side of the shape. And that indicates that the quantity on the left of the symbol is the smaller, and the quantity to the right of the symbol is larger. That's what's called the less than symbol. For example, you could write 7 is less than 8 by writing 7. And then you have this triangle where the point, the top of the triangle with no bottom, has been rotated to the left, and that pointy part is facing the 7. And the side with no base, the previous bottom, is open toward the 8 to the right. That's the less than symbol. X is less than Y. What's important to note is that both of these symbols mean that one quantity is less than, but not equal to the other quantity. That's important. This might be a little redundant when we're using numbers, but consider an expression with variables, such as x is less than 10. If I type x and then the less than symbol and then 10, what that means is x could be any value less than 10, but it cannot be equal to 10. So it could be 9.9999999, but not 10. That's an important part of the less than and greater than symbols that we just talked through. That might naturally lead you to the question, how can we express a value that could be equal to 10? We can use what's called a greater than or equal to symbol, or, as you might suspect, a less than or equal to symbol. To depict these situations, we use exactly the same symbols. We just draw a short horizontal line directly below the symbol. So again, we use the same greater than or less than, like triangle with no bottom that's been rotated either 90 degrees to the right or 90 degrees to the left, but with a horizontal line drawn right below it. And that makes it look kind of like half of an equals sign with a greater than or less than symbol right above it, if you can imagine that. Side note, on a Apple-based computer like a Macintosh, you can hold the Option key and then type the comma or period keys, and you'll see the symbol I'm talking about. Microsoft-based operating systems don't appear to have a convenient shortcut for this. I found a couple ways you could do it, but it was like kind of complicated, like 4 keystrokes. So I figured that's probably a little much. This greater than or equal to or less than or equal to notation will generally be used with variables. For example, you might see an expression like x is greater than or equal to 7. And what that looks like is you've got x on the left, and then you've got this symbol to the right of x with the bottom half of an equal sign. And then right above that bottom half of the equal sign, you have a triangle with no base rotated 90 degrees to the right. And so the larger part of the symbol, the part that was the bottom of the triangle, is opening toward x, denoting that x is larger. And then it's closing and coming to a point pointing towards 7 to the right. And that's denoting that 7 is the lesser of the values. So if we have x greater than or equal to symbol 7, that means x could be equal to 7, or it could be any value larger than 7. Again, that's different from the regular greater than symbol. If I write x greater than 7 without the horizontal line underneath, that means that x is definitely not 7, only a quantity larger than 7. So that's why we have the greater than or equal to symbol in addition to the regular greater than symbol. They can depict slightly different, but importantly different situations. So those are the basics of the symbols. Let's dive into how to operate on inequalities. And if you have questions on any of this stuff or you feel any of it is not clear, please just drop us a DM at the GMAT strategy on current social channels, and we'll be happy to help. So how do we operate on inequalities? Great news. All the same rules of equations apply to inequalities, but there's one giant new rule. If you multiply or divide both sides of an inequality by a negative value, you invert the sign. Let me say that again because it's super, super important. Many GMAT questions are going to hinge on this idea. All the same rules of equations apply to inequalities. All the same rules, but there is one additional big new rule, which is that if you multiply or divide both sides of an inequality by a negative value, you invert the sign. Now, you don't have to worry about this with equations, but with inequalities, it's a really big deal. So let's take the example of 5 less than symbol 6. I think we all can agree that 5 is less than 6. What happens, though, if we multiply both sides of that inequality by -1, like we might do if we were simplifying an equation? Well, if we don't invert the symbol, then we would get -5 is less than -6. But if you think about it, that's actually not true. -5 is not less than -6. So that's why we have to invert the sign. And what I mean by invert is we turn it around to face the other direction. So the less than symbol becomes the greater than symbol, and the greater than symbol would become the less than symbol if we multiply or divide it by a negative on both sides. In this case, we would write it as -5 greater than symbol -6, which is true. Multiplying or dividing by a negative on both sides of an inequality inverts the relationship between the quantities. Again, we don't need to worry about that with equations. Let's do an equation example. If we have the equation 5 equals 5, and then we multiply both sides by a negative, we get the equation -5 equals -5. And that's still true. So there's no need for an additional rule. We're not inverting any relationships there. It's only with inequalities, when you're treating both sides with negatives, that you are going to invert the relationship. For example, if we know that 10 is less than 20, and we write that as 10 less than symbol 20, and then we divide both sides by -2, we would get -5 less than symbol -10, which is not true. Hence, we must flip the inequality sign to face the other direction. So again, if previously your expression used a greater than sign, and you multiply or divide it by a negative, we invert it to a less than sign. If previously your expression used a less than sign, and you multiply or divide it by a negative, we invert it to be a greater than sign. You might want to make a flashcard for that important concept if you feel like you haven't truly mastered it yet. But if this is all sounding super familiar, then great. Now, again, other than that extremely important addition, all other rules of equations remain the same. Let's briefly rehash those. The first rule is the golden rule, and that still applies. Whatever operation we perform to one side of the inequality, we perform that operation to the other side. And the only exception are operations that don't change the value of one side, such as distributing terms or rearranging like terms. If you're not sure what I mean by that, you might want to go back 2 episodes where I talk about the basics of the golden rule of equations. The second rule of equations also applies. You want to combine like terms when you can, and that works exactly the same. And the third rule also applies. Simplifying means you make terms disappear until you can't make any more terms disappear. That's the third rule, is that we just define what we mean by simplifying expressions and equations. In this case, we're defining what we mean by simplifying inequalities. So hopefully all of those are already really, really familiar. Even so, let's just talk through a couple short examples to drive these concepts home. Consider the inequality -3x plus 7 is greater than 16. So -3x plus 7 greater than symbol 16. Let's simplify by combining like terms and using the golden rule. A good first move would be subtracting 7 from both sides. If we do that, we would have -3x is greater than 9 because 16 minus 7 is 9. Then if we divide both sides by -3 to isolate x, we would get x less than symbol because we have to invert the sign, and then -3 to the right. So the result of simplifying -3x plus 7 is greater than 16 would be x is less than -3. That's the result. That's a really simple example, but hopefully it's enough to illustrate how some of these concepts would play out in practice. Let's do another one. Consider 3x plus 5 less than symbol 2x minus 7. And if you're on the pure audio feed, don't worry about the exact calculations I'm doing here. Instead, let's just focus on the principles, which is that we're using the same rules as equations and just inverting the sign if we multiply or divide by a negative value. So 3x plus 5 less than 2x minus 7. Let's begin by subtracting 2x from both sides. 3x minus 2x equals x by itself. So we would have x plus 5 less than symbol -7. Let's then subtract 5 from both sides to isolate x. -7 minus 5 would yield -12. So our result would be x is less than -12. In this case, we didn't need to multiply or divide by any negative values to isolate x, so the less than sign that we began with remains unchanged. Those are the basics of operating on inequalities. You can certainly see situations on the exam that are much more complex than that. But at the end of the day, even complex situations will be governed by these very, very basic principles. And that's why we're making this content for you right now. You really can't know this stuff too well. Now that you understand those basics, or hopefully understand them, there are just a couple more points to cover in order for you to be well set up here. So let's answer the question, what are compound inequalities? Compound inequalities are just multiple inequalities that have been combined into one single expression. For example, let's say you are given a set of inequalities like x is less than 10 and x is greater than 5. It's completely acceptable to leave them as is and just operate on the question with those two pieces of information separate from each other, but they can also be combined into what we might call a three-part inequality. And the way that would look is 5 less than symbol x less than symbol 10. So you have a 5 with the less than symbol pointing toward the 5 and the open part of it opening to the right toward x. And then you have another less than symbol pointing to x with the open part of it pointing to the right toward 10. And that tells you the same information that the previous two inequalities told you. X is greater than 5 and x is less than 10. But in some situations, it's a more convenient way of expressing that same information. And it could help you see or just internalize that x could be any value between 5 and 10, but couldn't be 5 or 10 exactly. The reason this is important to discuss is that the exam often uses this way of presenting inequalities. The exam likes to show you compound inequalities. It's not a huge deal, but perhaps obviously it's kind of scary if you see something like that on the exam and you're not sure what it means. Like that's not going to be a good situation. So mostly just trying to help you understand like what is that? It's also worth noting that compound inequalities can have as many items in them as you want them to have. So you could see compound inequalities which with many more than three terms. This isn't super common, but it's common enough that it's worth mentioning. For example, you might see a question that says A is less than B, which is less than C, which is less than D, which is less than E, which is less than F. So that would be written as A less than symbol B, less than symbol C, less than symbol D, on and on and on and on. And all that's telling you is that we have 6 unknown values, but we do know that A is the smallest, and that B is between A and C, but not equal to either one, and that C is between B and D, but not equal to either one, and on and on and on and on. Again, it's just really important that you're able to understand what something like that is telling you and not have to hit the panic button if it shows up. And if you have that basic concept down that I just talked you through, that's most of what you'll want to know about compound inequalities. One quick other point about these, though. It's also worth mentioning that you can operate on compound inequalities using the golden rule. And we would just adjust the golden rule a little bit to say whatever you do to one part of the compound inequality, do that same operation to all the other parts as well. It's not really a new concept. We're just applying it in a potentially new way. So, quick example, let's say that we're told that A is less than B, which is less than C. And then that's presented in the problem as A less than symbol B less than symbol C. We could add 1 to every single one of those terms without changing the relationship. If A is less than B, which is less than C, then A plus 1 will be less than B plus 1, which will also be less than C plus 1. And so that could be written as A plus 1 less than symbol, B plus 1 less than symbol, C plus 1 to the right of that, all in one expression. Perhaps obviously, the same is true of simplifying compound inequalities. We could multiply all the items by 2, we could divide all the items by 2, and importantly, if we were to multiply all the items by -2, ask yourself what would happen in that compound inequality. If we multiply all 3 terms by -2, what would happen? Hopefully you're thinking we would just need to invert all the signs. So instead of flipping one sign, we flip every sign. So for example, if we start with A less than B less than C, then it would also be true that -2 is greater than -2A is greater than -2B, which is greater than -2C. So it's the original expression, A less than B less than C. We multiply everything by -2. That inverts all the signs, and we wind up with -2A greater than -2B greater than -2C, which works. That's totally allowed. It's not something I've seen the exam use a lot, but it's totally fair game. So if something like that comes up, I just want you to be capable of performing that operation accurately. In a way, we could say there's not much that's new or different about compound inequalities, and that it's just a different way of presenting information. But I do want you to be familiar with it, like I just said, in case you haven't seen it before, or just maybe in case it's been a really long time. Again, Just to drive this home, compound inequalities are just multiple inequalities that have been combined into one expression. In fact, we could take the most recent example and turn it into a bunch of smaller inequalities if we wanted to, such as A is less than B, and then a separate expression that says B is less than C. And we could do that as many times as we wanted to with a larger compound inequality. But again, it's often more convenient to look at all the relationships together in one expression, and that's why compound inequalities exist. It is convenient. Now that you understand that, we can make one final point about the basics of inequalities, which is how you graph them on a number line. The main way that visual depictions of inequalities can show up on the GMAT, other than writing them out like expressions that are similar to equations like we were just doing, is seeing them graphed on number lines. So it is worth discussing how to visualize these. The most important thing to pay attention to is the symbol. Is it a greater than? Is it a less than? Is it a greater than or equal to? Or is it a less than or equal to? So those are the four possibilities. And you just really want to zero in on that. That's going to be the main thing that determines what the graph looks like. For example, let's say we wanted to depict x is greater than 3 on a number line. What we would do is we would draw a number line with the number 3 somewhere on it, and then maybe we would put some hash lines for like 4, 5, 6 or 2, 1, 0, -1, something like that. And then what we would do is we would draw an open circle either right on the line on the part that represents 3 or right above the number 3. Either way works. And that open circle means that 3 is not included in the range. By the way, but what I mean by open circle is the edge of a circle, but there's nothing filled in the middle. It's just white space in the center of the circle. That indicates that we're not including the number 3 in the range. So we've got an open circle on the number line right above 3. And then we do what's called shading the line to the right of the open circle. Again, we're depicting x is greater than 3, greater than but not equal to 3. What I mean by shading is that you're making the line thicker and darker. It's kind of like bolding some letters of text, and it emphasizes that the values are greater than but not equal to 3. And then usually there'll be an arrow at some point to the right of the line to indicate that it goes on forever. The exact same process applies to the less than symbol. If we want to graph x is less than 3, we put an open circle, again, a circle not with the center not filled in, it's white space in the center, right above the 3, and then we shade the entire line to the left of 3. And then in this case, because there's no limit on the downside of x, we would put an arrow symbol that shows it's going to infinity to the left. And that's just a visual depiction that all the allowable values of x are smaller than but not equal to 3. That's how you graph less than and greater than on a number line. Finally, if you wanted to graph x is greater than or equal to 3, you draw the exact same graph as x is greater than 3, except you fill in the circle that's above the 3. So when that circle is filled in, meaning there's no white space in it, it's all black on the exam, that means we're including 3 in the set. That means if you see this number line, x could be exactly 3 or any larger value. Now, if you have a graph of like x is greater than or equal to 3, but less than or equal to 5, then you just wouldn't have the arrow to the right. You'd have a filled in circle above 3, you'd have a filled in circle right above 5, and then you'd shade everything that's in between the 3 and the 5. But there's no arrows going in either direction because x can't go to infinity past 3 or past 5. Unsurprisingly, you can do exactly the same thing for x is less than or equal to 3. You bold everything to the left of 3, and you also draw a circle right above 3, and then you fill that circle in to denote that you're including 3 in the potential values of x. That's it. If you're comfortable with those concepts, you should be totally fine when dealing with number line questions on the GMAT. And coincidentally, those are all the basics of inequalities as well. There will be some more advanced concepts to discover as you progress, but you should be very well set up to integrate those down the line. And that's my goal with this series, is just to get you going with the basics so that when you're looking at GMAT questions and GMAT explanations and taking courses or doing free programs, that you understand the basics of the math so that you can start the learning and application process as quickly as possible. If you have any questions or feedback about any of this material or anything in this series, please find us at the GMAT Strategy on current social channels and shoot us a direct message. And if you'd like a bit more practice with these concepts, most popular generative AI chatbots can provide you with a couple practice questions with a simple prompt like generate 10 questions that will help me improve my basic GMAT inequality skills. Something like that works well. Quick note on that. If you decide to go that route, I've noticed that many of those tools will automatically include a concept called absolute values. So please skip over those for now. Next time, we'll be talking all about the basics of absolute values and how they relate to inequalities. But that, in my opinion, is a topic that's best addressed in a separate lesson. So, as always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the GMAT, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video on how you can reach your dream GMAT score in half the normal time. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies. Talk to you all soon.